He must cut through the old floorboards, clear a path to the original ground level, and make room for a mini excavator. But deep within the subgrade, he discovers forgotten relics from the barn's past. An old horse-drawn sleigh, possibly used for winter journeys to church or town, when deep snow made wheels useless. Then comes what appears to be the steering of a larger wagon. And finally, a wooden farm cart. These probably handled the daily chores at the homestead long before modern tractors arrived, just about 100 years ago. But the clearing has only begun. The work now shifts to the upper equipment loft, where snowmobiles are still stored. It will be taken down completely, and then rebuilt above the new workshop. With the upper storage structure gone, he now starts a high-stakes balancing act between clearing space and keeping the building from structural collapse. On the southern wall, he reopens an entrance that had been sealed for years. This is where his new windows will sit. By contrast, the inner wall cannot be removed without risking collapse. But the mini excavator still needs access inside the barn, so Daniel decides to cut only an opening for now. Restoring this historic homestead is a massive project for Daniel. His current goal is building an affordable, highly insulated dream garage, so mechanical work can continue even through the harsh Swedish winters. It must be heavily insulated and powered by a massive radiant heating system, equipped with a heavy-duty garage door, a recessed scissor lift, and a custom professional workbench. But clearing the building was just the start. The real challenge is excavating beneath the structure to make room for the new foundation. Pushing the excavation to its limit, he digs directly under the walls until the entire timber shell rests solely on its original cornerstones. The next step is simple in principle, but precarious in practice. He uses hydraulic bottle jacks to bear the weight of the walls while he removes the last support beneath each corner. The weak soil must be replaced with compacted gravel for stability and drainage. The process must be repeated at all four corners while keeping the shell level. In theory, the idea is simple. In practice, it means lifting the barn itself. Suddenly, the need for this becomes clear. At the next wall, the lowest log has rotted through, and the damage is too extensive for a partial repair. The whole timber must be removed, leaving the wall weaker and one log shorter than the rest of the structure. So Daniel straps the loose logs together and adds an exterior jack to help support this corner. The entire shell must be lifted even farther to release this oversized cornerstone, alternating between the jacks to keep the shell level as it rises. If the barn leans too far to either side, its own weight could bring the walls down. The boulder is out, but the last corner is just as weak and unstable. So Daniel switches to a mechanical wall jack to raise it from the center. Once the load is secured, he quickly excavates the old footing and sets the new foundation. With the old interior gone and the barn lifted out of the way, the groundwork for the new garage can finally begin. He begins with a small slab to mark the foundation's lowest point. To survive the subarctic environment, the main floor requires severe engineering. Across the 650 square foot, the floor will be a layered system. Compacted gravel, insulation, hydronic heating lines, steel reinforcement, and finally, the concrete slab. Unlike the soil removed from beneath the barn, gravel drains freely instead of holding moisture. With no water available to freeze and expand, the slab should be safe from frost heave and cracking. Above the gravel, he installs a double layer of expanded polystyrene to create a thermal barrier. This serves a dual purpose. It keeps the freezing subsoil temperatures away from the concrete slab, while also preventing the valuable radiant heat from wasting downward. But the true gem of this assembly is the active heating system. Hundreds of feet of flexible tubing conduits are looped across the floor. Once permanently encased inside the structural concrete, circulating hot fluid through these pipes will transform the cold stone surface into a massive thermal battery. This will be a highly engineered foundation built to withstand the subarctic winter. That is, if he can manage to pour nearly 15 tons of concrete by hand to avoid hiring contractors. Daniel begins the 15-ton pour alone, using only his excavator, a drum mixer, and a wheelbarrow. Across 650 square feet, the method is painfully slow, but a concrete truck and professional crew could cost as much as $20,000. So Daniel changes his strategy and has two of his closest friends join the effort. Mixing, transport, and leveling now move in sequence. Under normal conditions, pouring a slab this large in small batches risks uneven setting and weak seams known as cold joints. Here, the cold slows the concrete's initial set, extending the window in which each new load can blend with the last, allowing the team to merge 7 hours of cartloads into one single slab. Yet the same cold could damage it if the fresh concrete freezes. Having foreseen this, he temporarily hooks the system to an old water heater. Eventually, a massive boiler system will feed this radiant heat. But for now, he fills the loops with antifreeze instead of water. This warm fluid can now circulate through the concrete, helping the slab cure without freezing, turning the unfinished heating system into a curing system. The new foundation is ready, and the workshop walls will soon begin rising inside the empty barn. But before he can focus on the interior, he must secure the exterior. The large southern opening is positioned to capture sunlight and will eventually hold the workshop windows. For now, it must remain sealed until spring so he can work inside. Timing is critical. The long snow season is approaching, and the freezing northern winds are already here. Daniel's plan is to build new framed walls inside the barn, creating a second heavily insulated room within the old shell. The first inner wall is assembled flat as a single timber stud panel. Building the panel is straightforward. Raising its full weight is not. Working alone, Daniel uses temporary timber props to lift the wall in stages until it can stand and be secured. Once again, for the second wall, he improvises a way to raise it by himself. Most of his work is usually solved with simple tools and creative solutions. This approach was shaped by years of rebuilding this old farm. He has gradually transformed it into a modern working homestead, one that now depends heavily on machinery. But machines need maintenance. Sending equipment away consumes time and money, while repairing it outdoors becomes almost impossible at sub-zero temperatures. The workshop will allow those repairs to happen here, where the machines are needed. With the third wall up, the framing process stops. A new opportunity has emerged to secure the steel beams required for the roof structure. Years earlier, an old steel bridge was demolished to make way for modern infrastructure. Its heavy beams were left behind, slowly disappearing beneath rust and vegetation. Instead of buying new steel, Daniel turns to the rusted remains. He recovers the usable sections, removes the old joints, and cuts them to length. Once the corrosion is removed and the metal receives a protective coating, the forgotten bridge sections are ready to carry a structure again. The reclaimed steel now spans the workshop between the two new walls, ready to carry the roof that still rests on the old log wall supports. Before he can safely demolish it, this load must be transferred into the new beam. But the relentless subarctic winter has arrived. Across a roof this large, the accumulated snow could easily add more than 20,000 pounds. To safely execute the load transfer, Daniel must clear the heavy snow. But the snow has frozen tightly to the roof and refuses to move. So Daniel changes tactics and decides to warm the roof from inside. The rising temperature melts the thin layer of ice bonding the snowpack to the roofing, allowing the accumulated snow to break free. With the extra weight removed, he can finally shift the support columns onto the new steel beam. The old interior log wall is now ready to come down. With the last interior obstruction removed, the full workshop span is finally visible, and the new inner shell is beginning to take shape. He can now assemble its largest wall. The framing follows the same method as before, but raising such a long panel is a different challenge. Its size makes the frame both heavy and vulnerable to twisting. Working alone, Daniel must raise it in careful stages, using temporary supports and improvised leverage to secure each gain. Once it is high enough, he uses the chain hoists to pull it through the final lift. With the largest wall standing, he can finally raise the second steel beam, completing the basic structural box of the new garage. He then turns to the southern wall. At this northern latitude, south-facing, sun-bearing openings are a huge advantage, so he frames it around a pair of salvaged windows for a perfect fit. The final wall will house a full-size garage door, wide enough to bring his heavy machinery inside. With the frame walls and steel beams in place, the basic box structure is now complete. Next, Daniel has to move upward and start building the new ceiling that will separate the workshop from the loft above. The upper storage loft was dismantled at the beginning of the build. He will now rebuild it as a practical space for equipment and snowmobiles, but this time it will be enclosed separately from the workshop below. With the upper joists secured, the structural skeleton is now complete, spanning both the lower workshop and the storage loft above. Now it must be sealed and insulated like a giant cool box. He starts with a foil-faced air and vapor membrane across the ceiling. Heat naturally rises, and this membrane is engineered to bounce radiant energy back down into the workshop. Once its seams are taped, the membrane restricts air leakage and prevents warm indoor moisture from reaching the colder layers, where it could condense inside the structure. His next objective is to close off the upper loft. Because this elevated level will serve only as storage for equipment and snowmobiles, it requires no heating and must remain separate from the workshop below. Working alone has long been central to Daniel's approach. He is systematically restoring this historic homestead himself. Using his professional experience as a contractor, he replaces expensive commercial crews with his own time and advanced engineering skills. But as Daniel prepares to close the opposite wall, he pauses to reconsider the framing. The elevated opening overlooks the workshop below, and he begins wondering whether it could become a more useful interior space. His answer is to construct an interior balcony, a cantilevered space he can later use as a quiet, elevated area to relax and oversee the shop floor. Once its basic frame is secured, he closes the remaining wall using the same studs and boards method he used on the opposite side. Working alone keeps the build moving, but it can be tricky too. With the enclosure complete, the focus shifts from structure to climate. To withstand a Swedish winter, every wall and ceiling must now become one continuous thermal barrier. He utilizes thick blocks of glass wool, a high-density fiberglass insulation designed for severe climates. These bats work on a simple but powerful physical principle. They trap millions of microscopic pockets of air within their fibers. Because still air is an exceptionally poor conductor of thermal energy, these slabs act as a barrier, stopping the workshop's heat from escaping into the freezing exterior. The insulation marathon reaches the narrow spaces between the new shell and the old roof. Altogether, nearly 1,800 square feet must be covered. Approximately 250 pieces of insulation installed by one man. By reaching the upper loft, the insulation work finally appears to be done. But there is only one way to know whether it works. Heat the workshop. Daniel has been working at barely 5 degrees Fahrenheit, and these subarctic conditions require more than a domestic solution. He brings in a torpedo heater. This machine operates on principles closer to a jet engine. An internal pump pulls diesel and atomizes it under high pressure, spraying a fine, highly combustible mist into a burner. The workshop climbs from 5 below to 68 degrees Fahrenheit, a temperature rise of more than 70 degrees. Daniel now scans the room with a thermal imaging camera. The insulated walls appear warm and consistent, with no visible thermal leaks, while the concrete floor remains a stark reminder of what the temperature was just a moment ago. But heating the workshop creates a new urgency. If the heated, humid air from the workshop is allowed to drift into the walls and collide with the subarctic temperatures, it will rapidly condense back into liquid water. This moisture would breed destructive mold deep within the wooden framing. So the next step is to wrap the entire interior in a plastic vapor barrier and tape every seam tightly closed. This plastic layer will keep the warm, moist indoor air completely isolated from the freezing outer walls. With the walls sealed and the new garage's thermal envelope almost ready, it is time to focus on the exterior openings. Daniel decided to add a smaller pedestrian entrance, but before cutting through the wall, he must brace the old logs to keep it stable. Using the garage entrance for everyday access would dump valuable heat into the winter air. So he sourced a second-hand door for daily use. This small investment will save him hundreds in heating costs. His new door is now ready, but the main garage door has yet to arrive, leaving the largest opening in the building completely exposed. To keep the thermal envelope intact, Daniel must improvise a temporary insulated barrier. Fortunately, a conversation with his father provides a promising low-cost solution. Using the existing tarps to create a temporary hanger-style door. Wooden ribs will preserve the gap between the two tarps, while a pulley system will allow them to fold upward like an improvised garage door. The air trapped between the two plastic tarps acts as an insulating layer, much like the sealed gap in a double-pane window. The idea is unconventional, but inexpensive and mechanically simple. So Daniel decides to put it to the test. The temporary door is hardly elegant, but it works. He brings his car inside as the workshop's first test subject. At 22 degrees below zero outside, it becomes living proof of why this climate-controlled space is necessary. Repairing the farm's heavy machinery in the open is simply not an option. His father's idea seems to perform much better than he expected. But the work suddenly pauses, interrupted by a rare opportunity. The exact hydraulic scissor lift Daniel has been looking for appears on a second-hand marketplace. Its dimensions match the recessed bay already built into the slab, and the asking price is unusually good. The bad news is that it is 400 miles away. With the lift secured, Daniel faces a 16-hour, 435-mile drive home through the subarctic winter. This is the exact lift Daniel had planned around. It raises vehicles and machinery to provide the undercarriage access required for serious mechanical work. A comparable new model could cost more than $6,000. He secured this one for a fraction of the price, but first, it must prove that the bargain actually works. The platform rises smoothly, then disappears back into the floor exactly as planned. With the lift operational, the focus shifts back to finishing the interior walls. But just 200 miles south of the Arctic Circle, there is no such thing as excessive insulation. Before the cladding can close the walls, he adds another layer of dense stone wool across the framing. This interrupts the thermal bridges created by the solid timber and forms a service cavity for the electrical wiring, keeping it safely away from the vapor barrier. He can now install the final cladding for his new garage. He chooses white corrugated sheet metal, a durable and affordable surface commonly suited to industrial spaces. The long steel sheets are flexible and difficult to position overhead alone, but rather than bring in an outside crew, he relies on his own resourcefulness and engineers a simple, custom wooden support bracket. This cladding will provide a fire-resistant barrier and can withstand the punishment of a working garage. When the remaining panels extend farther beyond his reach, Daniel upgrades his homemade bracket. With little more than a few timber offcuts, he turns it into an extended overhead jig, an inexpensive DIY hack that supports the entire sheet in place. With the modern, climate-controlled garage finally taking shape, Daniel can begin hunting for the massive boiler system that will heat it. But first, the good news keep coming. The real garage door is finally here. The weight came down to specification. Daniel needed an insulated sectional door matched precisely to the rebuilt opening, with enough clearance for the farm's larger machinery. Unlike a standard door available from stock, the specially configured system required a longer manufacturing lead time. With the garage door installed, the focus now shifts outside. Daniel has finally located the heating system he has been searching for. Before it can be installed, he must rebuild the missing sections of the facade, or the new system will waste its heat outdoors. Above the workshop, laying the floorboards returns the upper loft to usable condition. It is a major milestone. Dismantled at the beginning of the build, it can finally be used again. He is finally ready to tackle the next major challenge. The massive heating system has arrived. To install it, he must build a dedicated boiler room in the adjoining section of the barn. The system has three main components: a central burner and two massive accumulator tanks. The boiler transfers heat from the burning wood into water, while the tanks store that energy until it is needed by the radiant floor. It is an older system, but still highly efficient. Daniel found the complete setup secondhand for under $400, a fraction of the roughly $10,000 a modern equivalent could cost. With the copper piping fully soldered, he installs the chimney, building a specialized cinder block maintenance trap at its base. Every wood-fired system eventually leaves deposits in the flue. This trap allows him to remove the residue without dismantling the chimney. With the flue carried through the barn roof, the boiler is finally ready to fire. The system performs exactly as intended. Heat flows into the circuits buried beneath the concrete, and the foundation slab finally takes over as the workshop's main heat source. Buried in a dealer's old inventory, Daniel found another near-perfect bargain. The door he needed. Unsold for years, he was able to secure it for almost nothing. With the wood-fired boiler fully operational, it is time to connect the new boiler room to the main garage. He anticipated this when the wall was built. With the opening already framed behind the surface, he only needs to cut through the metal cladding and insulation before setting the door into place. He can now manage and feed the heating system without ever having to walk outside around the barn in the freezing winter. And on the opposite end of the garage, he can finally start building the long-awaited workbench. Daniel started this project with one goal in mind: creating a professional-grade, dream garage while spending as little money as possible. So building his own workbench and cabinet system from scratch was always an essential part of the plan. The lower cabinets begin with a timber framework. Because the concrete floor slopes toward the drain, he installs adjustable feet beneath the base, allowing every section to be leveled before the frames are connected. He installs the scissor lifts control box directly into the workbench frame. The result is a compact, professional arrangement that keeps the controls protected and within easy reach. Upper cabinets will extend the storage vertically. Along their underside, he recesses a continuous LED strip, directing uninterrupted task light across the bench below. This will provide an evenly lit work surface and a high-end finish without the premium price tag. The upper cabinet doors are also fabricated from scratch. Each panel is cut to size, drilled for hinges, and mounted individually until the framework becomes a continuous wall of storage. For the countertop, timber alone would not survive heavy mechanical repair work. So he builds a thick timber sub-base and glues down massive sheets of stainless steel. He uses clamps and heavy barbell plates to hold the steel perfectly flat while the adhesive cures. This will be a heavy-duty workstation, but it also needs serious storage. The lower drawers demand even more work and precision. After mounting dozens of drawer slides, Daniel now builds all 20 individual boxes by hand. Using tape, spacers, and a straight edge, he aligns each drawer face before fastening it permanently from inside. What emerges is a custom industrial workstation, built for the garage without the industrial price. A wall-to-wall system like this could cost nearly $10,000. He has just built his for a fraction of the price. Still, Daniel's ambitions continue to expand, and now he wants to engineer a custom personal lift to access the balcony. But sunlight comes first. The new windows remain blocked behind the unfinished exterior shell. It is time to bring in daylight. Months ago, he sealed this opening against the approaching winter. Now, he must finish the shell for good. From the outside, the barn still belongs to the old homestead. Its red timber walls preserve the familiar silhouette that has stood here for generations. But behind that shell now lies a sealed, heavily insulated modern workshop. Completing the south-facing wall finally allows daylight to reach the workshop throughout the year. With the building closed, protected, and illuminated, Daniel can turn to his most ambitious project yet: the custom elevator lift. His idea is to access the balcony using an electric hoist and paired strut channel rails. The hoist carries the load, while the rails guide the platform. For the rails, he 3D prints profile-matched standoffs, creating a consistent mounting plane that keeps both rails aligned. Inside each channel, paired ball bearings form the roller carriages. But the first test fit reveals a critical clearance issue. The mounting bolt heads would be in its way. Instead of rebuilding the steel assembly, Daniel returns to the 3D printer and produces custom roller sleeves. By increasing the bearing's rolling diameter, they raise the carriage just enough to clear the fasteners inside the rail. Problem solved, and Daniel gets back to building. He welds a custom frame from rectangular hollow section steel. It must be large and strong enough to carry a person, additional load, and fit the hoist itself, yet light enough to remain within the motor's lifting capacity. He adds a pulley to redirect the cable. His idea is to conceal the entire mechanism inside the platform, but the hoist is too tall to fit vertically, so he mounts it sideways. With the hoist welded into place, only one question remains: will it work? The concept proves sound. The platform rises smoothly, and the elevator works. With the hoist operating correctly and the carriages gliding through the rails, he can finally commit to full welds and reinforce the platform for permanent use. This time, he is confident enough to test it with his own weight. But a working lift is not yet a safe one. 3 major improvements still stand between the prototype and its final version. The first is straightforward, controlled stopping. Limit switches at both ends of the travel cut power automatically, preventing the platform from moving beyond its intended upper or lower position. The second is cable management. A modified retractable reel keeps the power cable under constant tension, feeding it out and winding it back in without leaving dangerous loops that could enter the guide rails or become trapped beneath the lift. The third and final is far more ambitious. To protect the platform if the hoist cable ever fails, he must engineer an emergency brake. And at its heart will be an unlikely component: bicycle brake pads. Mounted inside custom spring-loaded brackets, they sit ready on both sides of the carriage. If released, the pads bite into the rails and wedge the platform in place. A cable tension trigger will control both brakes. Under normal operation, the taut hoist cable holds the mechanism open. If that tension disappears, the trigger releases the springs and drives the pads into the rails. Daniel devises an unorthodox drop test to prove it. He secures the platform to a strap with zip ties and introduces slack to the hoist cable. By slicing the ties, he will simulate a failure and send the carriage into a dead drop. They respond instantly, locking the platform to the rails. Daniel has designed and built his own autonomous emergency brake. With the system proven, the result is an exceptional piece of DIY engineering. A custom elevator designed and built from scratch, with the hoist, cable management, and safety systems concealed neatly inside the platform. Now fully operational, the lift is ready for its first proper passenger. A friend comes over to try it, and together they can finally take in the completed modern garage. What began as a decaying timber shell now stands as a heated, fully equipped professional workshop, built to keep the machinery and the homestead moving. The barn has not lost its history. Its familiar exterior remains, but inside, Daniel's commitment and skills have given it a new purpose and a future strong enough to outlast many more Swedish winters.